Speech involves conceptualization, linguistic planning, motor planning, and programming. The neuromotor system of speech forms a foundation for the control of movement. It has components of a central and peripheral nervous system for the control of coordinated movement. The motor system is responsible for conceptual programming to establish the goals of speech production. Linguistic programming makes use of attention and memory processes to produce a verbal message. Motor planning or programming involves phonological representations for motor movement of speech that set parameters for motor contraction or movement. The Broca's area, together with the supplementary motor area, are highly involved in the subconscious planning and programming of the muscle movement sequence. Broca's area is for simultaneous and sequential movement, where the central nervous system generates commands that travel from the upper motor neuron and synapse with lower motor neurons. The upper motor neurons include pyramidal, which are direct and monosynaptic tracts, while the extrapyramidal has multisynaptic tracts. The pyramidal tract carry messages for voluntary motor movements to the lower motor neurons in the brainstem and spinal cord. Under the pyramidal tract, the corticospinal tract has fibers that synapse with the cranial nerves and pass information on voluntary actions to skeletal muscles. It starts with the primary motor cortex and two neurons, one for axial and one for appendicular muscles. The information leaves the cortex by descending to the brainstem. Eventually, fibers go down to the lateral and anterior corticospinal tracts and decussate to the anterior wide commissure. They then synapse to the neuron in the anterior horn of the gray matter that project fibers towards the limbs and axial muscles. The corticonuclear tract is formed by fibers that the cranial nerve synapses with. These innervate cranial nerves and make voluntary pathways for all speech muscle movements except respiration. The corticopontine tract descends and synapses with the lower motor neurons and fibers that end at the pons. They carry information to the cerebellum. The extrapyramidal system is responsible for autonomic and gross motor movements. They inhibit interference with muscle movements for appropriate speed and direction. The basal ganglia also inhibits rapid firing of motor neurons. The cerebellum motor subsystem influences the other motor systems in speech production. Because the cerebellum interacts with the pyramidal and extrapyramidal system for coordination, this results to precise control of speech movement.